This is tutorial 3, question 4. And first of all, for question 1 and question 3, it doesn't have any sound because I have a problem with my microphone. So for those two question doesn't have any sound, and we start at question 4. Alright, so for question 4 is liquid toluene C7H8, which the specific gravity of 0.866 is flowing through a pipe at the rate of 175 meter cube per hour. So for part A, it wants us to convert to kilogram per minute from 175 meter cube per hour. So the final result for part A is in kilogram per minute, and initially it gives us 175 meter cube per hour. So we need to convert hours to minute first. So an hour is equal to 60 minutes. And then we need to convert meter cube into kilogram. So we need to use the specific gravity given. So specific gravity is the P of toluene, the density of toluene, over the P reference. So the P reference is 1000 meter cube, kilogram per meter cube. So since the SG is given 0.866, so 0.866 is equal to P toluene over 1000 kilogram per meter cube. So P toluene will be 866 kilogram per meter cube. So we have 866 kilogram per meter cube. So we cancel out this, cancel out meter cube, and then we only have kilogram per minute, which is the amount needed. So with the calculation, we will get 2528.5 kilogram per minute. Alright, so that's part A. We move to the next part, which is part B. Alright, so for part B, it wants us to convert from mass flow rate to molar flow rate, which is in mole per second. So for part B, the end result will be mole per second. So so what's the value in the first value? In part A, before we get 2528.5 kilogram per minute. So we convert the minute into seconds, so 1 minute is equal to 60 seconds. So from kilogram to mole, we can use the molar mass of toluene, which is C7 and H8. So molecular mass of toluene is about 92.14 kilogram per kilomole, or gram per mole, whichever you want. So I'm using 92.14 kilogram per mole. So to get mole per second, so we need to inverse it. So we need to divide it by molecular weight, which in terms we get 1 kilomole over 92.14 kg. So we can cancel out the minutes and we can cancel out the kilogram. In the end, we get kilomole per second. So the value is about, with calculation, we get 0.457 kilomole per second. But since the question wants us in mole, so we can convert kilomole. 1 kilomole is equal to 1000 mole. So 1000 mole equal to 1 kilomole. So we can cancel that out. So it's end up with 457 mole per second. Alright, so that's question 4. We move to the next question. This is question 5 from tutorial 3. So this question stated a mixture of methanol and methyl acetate contain 15% by weight of methanol. So it's only out of this mixture only 15% by weight is methanol. So if 100 grams of mixture is only has 15 grams of methanol. So for part A, it wants us to determine the moles of methanol in 200 kilogram of mixture. So A, so since we have 200 kilogram of mixture and it's stated that only 15% of it is methanol, so we can find how many methanol in it by times 15 divide by 100. So basically you divide it by 100% of it and get 15% out of it. So you only get out of 200 kilograms only 30 kilograms of methanol. Alright, so it wants us to get in moles. So moles is, for the formulation, is mass divided by molar mass, mR. So mR for methanol is 32.04 kg per kilomole of methanol. So to find the mole of methanol in this 200 kilogram mixture is, so only 30 kilogram of methanol exists, divided by 32.04 kilogram per kilomole. So in the end you get about 0.936 kilomole of methanol. Right, so since 1 kilomole is 1000 mole, so you time it by 1000 mole for 1 kilomole, so you get 936 mole of methanol. Alright, so that's part A for question 5. We move to part B. For part B, it gives us the flow rate of methyl acetate in the mixture is to be 100 pound mole per hour. The question wants us to convert the mixture flow rate in pound per hour. So we need, so it gives us the amount of methyl acetate in pound mole per hour. So we need to convert this to the mixture flow rate, which is the overall mixture. So methyl acetate is 85% of the mixture, while the other 15% is methanol. Alright, so at first we need to determine the mass because we need to convert mole to mass. We are lucky here because this is pound mole and then the mass is in pound lbm. So to get mass from mole, is, so mass equal to mole times by the molar mass of a methyl acetate. And molar mass of methyl acetate is 74.1 kilogram per kilomole, and we can convert this similarly to 74.1 lbm over lb mole, because both of these are in pound and these are in kilogram and kilomole. Alright, so pound to pound, kilogram to kilogram, kilo to kilo. Alright, so the conversion here is we have 100 lb mole per hour, and then we times it by 74.1 lbm over lb mole. Alright, so the value will be about 7,410 lbm per hour. Alright, so this is the mass of methyl acetate alone. So the question wants us what's the mixture flow rate. So the total mixture flow rate, so 7,410 pound per hour is only for methyl acetate, so we have to add up at 15% weight of acetate. Alright, so this is only 85%. So mixture mass flow rate is 7,410 per hour, and we divide it by 85% because this is 85%, and we times it by 100 to get the total amount. So the value will be about 8,715 lbm per hour. Alright, so that's logical because 7,410 is 85%. You add up the extra 15%, so it'll be 8,715. Alright, so that's question 5. We'll move to the next question. This is question number 6, and the question stated the feed to an ammonia synthesis reactor contain 25 mole percent of nitrogen, and the balance is hydrogen, and the flow rate of the stream is 3,000 kilogram per hour. So this question wants us to calculate the rate of flow of nitrogen into the reactor in kilogram per hour. So this stated that ammonia, which is NH3, goes into the reactor, and it contains 25% mole of hydrogen, and the balance is hydrogen. So because of it has 4 atoms in one molecule of NH3 has 4 atoms, so 1 atom of nitrogen plus the other 3 is hydrogen. So 1 nitrogen is equivalent to 25 mole percent of the total amount. So the flow rate of the stream is 3000 kilogram per hour, which means the flow rate of the nitrogen, the ammonia, sorry. So let's say mole, the formula is mass over molecular weight. So we were given the mass, and we need to find the molecular weight in order to find the mole of ammonia into the stream. So molecule of ammonia is NH3, which nitrogen atomic weight is 14, while hydrogen is 1, and we have to times it by 3. So molecular weight for ammonia is 17. Alright, so now we can find the molar flow rate of the ammonia stream. So it was given 3000 kilogram per hour. So 3000 kilogram per hour and divided by the molecular weight, which is 17 kilogram per kilomole. So that can cancel out, and then we get 176.47 kilomole per hour, and this is kilomole of total ammonia. So this question wants us to find the nitrogen flow rate in kilogram per hour, and since 25 mole % of nitrogen is equivalent to 1 mole of nitrogen in the ammonia itself, so the amount of nitrogen flow rate, the molar flow rate of nitrogen in the stream is equivalent to the total mole of ammonia, because 1 mole of ammonia contains only 1 mole of nitrogen. If 1 mole of ammonia contains 2 mole or 3 mole of nitrogen, then you have to consider the ratio of hydrogen and nitrogen in there. But in this case, the amount of ammonia is the same amount of nitrogen in terms of mole. So we have 176.47 kilomole per hour of nitrogen. So we have 176.47 kilomole per hour of nitrogen, and we want it in kilogram per hour. So same thing, we want the mass flow rate here. So in kilogram per hour, we need to multiply the molar flow rate by the molecular mass of nitrogen, the atomic mass of nitrogen, because nitrogen is an atom. So to find the mass flow rate, which is in kilogram per hour, we need to multiply this amount, kilomole per hour of nitrogen, 176.47 kilomole per hour, and then times it. The atomic mass for nitrogen is 14 kilogram per kilomole, and then the value will be 2471 kilogram of nitrogen per hour. Alright, so that's question 6. We move to the next question. This is question number 7, and the question, it says that a mixture is 10 mole % of ethyl alcohol, which is typical ethanol. 75 mole percent of ethyl acetate and 15% mole of acetic acid. So there's three parts in this question. First, it wants us to calculate the mass fraction of each compound. The second one is to find out the average molecular weight of the mixture, and the last one is what would the mass of a sample containing 25 kilomole of ethyl acetate. So it gives us the amount of ethyl acetate, and it wants us to find what is the mass of the total mixture. So let's do the first and second part first. So for part A is calculate the mass fraction of each compound. So it gives the question gives us the mole percent of a mixture, and so we have to convert it to the mass fraction. So percent of mole to the percent of weight. So let's let's choose a basis. Let's choose a basis of 100 mole of mixture. So there's 100 moles of mixture, and from this 100 mole, the 10% is, so there will be 10 moles of ethyl alcohol, and then 75 moles of ethyl acetate, and then the last one is 15 moles of acetic acid. Alright, so now we need to convert these moles into the mass of each compound. So to find the molecular mass is the mass. First we need to find the molecular mass of each compound. So ethyl alcohol, which is typical ethanol, which has a molecular weight of 48 grams per mole, and then ethyl acetate is 88 gram per mole, and the last one is acetic acid is 60 gram per mole. So to get mass from the formula, mass of each compound is we need to multiply the mole with the molecular weight of each compound. So for ethanol is 10 moles times by 48. So we will get 460 grams of ethanol. Oh, sorry. So oops. So it's not 48, it's 46 gram per mole, which is, yeah. And next one is for ethyl acetate. So 75 moles times 88 gram per mole, we will get 6,600 grams. And the last one is acetic acid, which is 15 times 60. We'll get 900 grams. So now is calculate the mass fraction. Mass fraction is the mass of each compound divided by the total mass of the whole mixture. So the total mass of the whole mixture in 1,000 moles, which is our basis, is 77,960 grams. So mass fraction is, we can calculate for alcohol, is 460 divided by 7,960, and we'll get about 5.78%, which is you have to multiply by 100. This is just a rough. And then for ethyl acetate, this is the big one, which is 6,600 divided by 7,960, and you get about 82.91%. And the last one is acetic acid. Just go down a bit, which is 900 divided by the total mass, 7,960, and you get a value of 11.31%. So you add up all of these, it's equal to 100%. So converting 10% mole of ethyl alcohol, we'll get only 5.78 weight percent of alcohol in the total mixture, and for acetate from 75% you get 82.9, and for acetic acid from 15 you get 11.3%. So that's percentage by weight. And then for the second part is what's the average molecular weight of the mixture. Average molecular weight is the average molecular weight is the total amount of weight, the mass, and divide by the mole, the total mole of the mixture, which is we use the basis of 100 moles, and the total mass is 7,960. So average molecular weight will comes out as 7960 gram divided by 100 moles. So you get 79.6 gram per mole. Alright, so this is the average molecular weight of the mixture. So we move to the last part of this question. This is part C of the question 7, and it wants us to determine the mass of a sample containing 25 kilomole of ethyl acetate. So this mixture contains 25 kilomole of ethyl acetate. It was given, so we need to find what's the kilomole of ethanol, ethyl alcohol, and how many acetic acid available, and calculate the mass of those compounds, and finally determine what's the weight, the mass of the mixture. So let's start with ethyl acetate. So ethyl acetate, we have 25 kilomole, and then we need to find the alcohol, and the last one is acid. So this 25 kilomole is similar to amount of the percentage of ethyl, the mole percentage of ethyl acetate. So this 25 kilomoles is similar. So we need to find what's the amount of mole of ethyl alcohol and acetic acid. So this 25 kilomole for alcohol, this 25 kilomole is equal to 75% of the 75% mole percent of the mixture, and for alcohol is 10%, so we multiply it by 10%. So this 25 divide by 75 and times 10, and we'll get about 3.33 kilomole of alcohol. And then for acid, also the same thing, but acid is 15% out of the total mixture amount, so that's 25 kilomole. Still divide by 75 because we want to get the 1% and we multiply it by 15, so we get 5 kilomole. And now we have all the moles of each compound. For ethyl acetate is 25 kilomole, alcohol is 3.33 kilomole, and acid is 5 kilomole. So it wants us the mass in kg, so we can convert mole to kilogram by multiplying with the molecular mass. So for ethyl acetate is 88 gram per mole or 88 kilogram per kilomole. Since we have kilomole, we use 88 kilogram per kilomole. So it's 88 kilogram per kilomole. So for alcohol is 46 kilogram per kilomole. 46 kilogram per kilomole. And for acid is 60 kilogram per kilomole. 60 kilogram per kilomole. So by multiplying this value, we get 2200 kg of ethyl acetate, because this cancel out and this also cancel out. For alcohol, we get 153.2 kilogram, and for acid we get 300 kilogram of acid. Alright, so from here we already convert from mole to mass, so that's we almost there. And what would be the mass of the sample containing? So mass of the sample means the total mass of the mixture. So total mass of mixture is, well, the addition of all these two, the summation of all these two. So it's 2200 plus 153.2 plus 300 kilograms. All of this is in kilogram, so you get the value will be 2653.2 kilogram. Alright, so that's the final part for question 7. Now we move to the next question.